Hey, today we're going to be looking at exponent rules. There are three rules we have to know. First one is for multiplication, so I'm just going to write it here. So yeah, first one, if we have the same base, so x to the power of 2, all multiplied by x to the power of 3, we are going to get x to the power of 2 plus 3, which is equal to x to the power of 5. So for multiplication, we have to add the exponents. For division, you could probably already guess this, but if it was x cubed, all divided by x squared, this would be x to the power of 3 minus 2, which is equal to x to the power of 1, or just x. So if it's division, we have to subtract the exponents. The last rule is pretty simple as well. If you have an exponent to an exponent, so for example, x to the power of 3, all to the power of 4, you would actually multiply the exponents here. So you would multiply the 3 and the 4 together, and you would get something like x to the power of 3 times 4, which is just x to the power of 12. That's it. So recap, if it's multiplication, we add the exponents. If it's division, we subtract the exponents. If it's an exponent to an exponent, we multiply both exponents together to get the final answer. Okay, so we got a few examples here. First one is 3 squared times 3 cubed. For this one, it is super simple. We have the same base, and it's multiplication. So what we could do is just add the exponents. So this would be 3 to the power of 2 plus 3, which is equal to 3 to the power of 5. And we're done. Next one, super simple once again. You can just add the exponents because we are multiplying. So this would be 4 to the power of 2 plus 6, which is equal to 4 to the power of 8. And we're done once again. For these next ones, it's division. So what we learned before is that if it's division and it's the same base, we can subtract the exponents. So this would be 3 to the power of 2 minus 3, because 2 is on top and 3 is on the bottom. So 2 minus 3, which is equal to 3 to the power of negative 1. You might think, oh, it's a negative number. That's wrong. It's actually not. All this works for negative numbers, just like it works for positive numbers. So we are done. Next question, same thing once again. 4 to the power of 3 minus 9, which is equal to 4 to the power of negative 6. We're done. Next question, 2 to the power of 4 minus 6, which is equal to 2 to the power of negative 2. And we're done once again. So all we did here was we added for multiplication, and we subtracted it for division. That's it. These three next questions here, they are a bit different. But yeah, first one, we can already notice that we do not have the same base, so the 4 and the 3, and we can't really combine this. So the only way you would actually figure this out is by multiplying 4 squared and 3 to the power of 9. So 4 squared is 16, and then find whatever 3 to the power of 9 is, and then multiply them together using some calculator or using long multiplication. But you cannot combine these using the exponent rules that we just learned. But yeah, next question, same thing here. So we did not have the same base. We cannot combine these. So 2 to the power of 4 is 16. 3 squared is 9. And that's all we can do. You can find the answer of this using a calculator once again. But you cannot combine this using any of the exponent rules that we learned. This next question is a bit tricky, but it's actually a bit interesting as well. So 16 to the power of 5 times 4 to the power of 3. First, what we know is that 16 is equal to 4 squared. What this tells us is that we can substitute 16 for 4 squared and see what we get from there. So let me just do that. 16 is 4 squared, and then all to the power of 5, because this 5 just gets carried over there, and then multiply by 4 cubed, because once again, we're just copy-pasting the question. All we changed is the 16 to become 4 squared. Now we can use the other rule that we learned. So we know that an exponent to an exponent requires multiplication. So this would be 4 to the power of 2 times 5, which is 10. And then the next number is 4 cubed once again. This just copy-pasted right there. And then if you multiply these out, if it's multiplication, and now we have the same base, they are both 4s, we can add the exponent. So this would be equal to 4 to the power of 10 plus 3, which is equal to 4 to the power of 13. And we're done. This is the only thing you can really do with any of the exponent rules. You could try always changing the base to become the same on both numbers, But we couldn't really do that in these two questions because 4 and 3 don't have any common factors. And in this case, 2 and 3 don't have any common factors. So we can't really do that. It only works if, in this case, 16 was a power of 4. So that's how we did it. But yeah, that's pretty much it for all the exponent rules and a few examples.